Yeah, shoot, I don't even know. Let me just see. Wednesday. Just so we can have it on. Yep, I'm okay anytime Wednesday, so we could do 7:30.
Okay, I'll just text them right now. And say.
Yeah, perfect. So for him, 8:30.
Okay, so I guess let's just get going then.
Okay.
We don't have any questions about homework. We can just start with the quiz.
Well, there was one thing on here that said compare with 3 other people, which I thought we would just do in our group. But I don't know where it is now. Let me see. Oh, 7D. Compare your mean from question 7A to other people, and what do you notice?
Okay, so my mean was 45,840.
Mine was 45,260.
Okay.
So they were both right around 45, between 45 and 46,000. Yeah.
Yeah.
So they're kind of what the table says anyway. Okay.
Yeah, definitely.
Good.
So I guess since we don't have anybody else.
Yeah.
Okay.
So now we'll go to the quiz.
Hopefully it's short.
I know. Okay.
Oh man, it's 12 questions.
Okay.
Well, really.
Group
really
meeting, yes. And actively participate, yes. Yeah, really 10, good. Okay, you're required to work together, blah, blah. Here is the applet. Let's open it. Oops. Okay.
Okay, so when you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
What?
Yeah.
How is supposed to know that? What? Oh, if it's normal, then it comes out normal. So maybe if they only did 5 and it's right skewed, there's 1 all the way to the right. So that throws it all off. So maybe it's skewed right. That's my guess. I don't know. What is the shape? Oh, distribution of means. So the means, okay, wait, if it's normal, let me see.
I want to say it's right skewed because when we were doing the sampling distributions,
Mm-hmm.
and it had, oh, I don't know, actually.
But here, look, on the homework on number 6, when is X with a bar normally distributed? It says there are 2 situations.
Oh, actually, I think it's normal.
Yeah, if it's normal, if the parent population is normal, which this isn't, it's right skewed, but even if the parent population is not normal, the central limit theorem guarantees the distribution of the sample size, blah, blah, to be normal if the sample size O is large enough, n is larger than 30. Okay, so no, I don't think it is. I think it's going to be skewed right because it's n is 5, so few, but the next one says n is 100. Then I think it would be normal in question 4.
Then that would be normal.
Yeah.
Yeah.
Normal. Okay.
Yeah, because that's what I was thinking at first from that rule.
Mm-hmm.
But then I got confused. So
yeah. Okay, good.
Okay.
Number 5. When you're taking a sample size of 5, what is the shape of the distribution of means histogram when the parent normally distributed? Normal. Don't you think?
Second, when you're taking sample size, what is the shape?
Normal, yes. I think it is. And also normal on 6.
Wait, I'm confused. Hold on.
Okay.
Can we, I mean, are we allowed to use that distributions thing that we did earlier?
Which
where it like animates everything?
Yeah, I think so.
Because
the sampling distribution.
Clear the lower 3. N equals 5. It looks normal.
Oh, yeah, n equals 5. But if you do it 5, oh, 10,000. Yeah. So which one? So they're both normal, right? On question 5, normal. Because it says the parent population is normally distributed. That's the whole, I think that's the whole thing on it.
So 3 is normal, 4 is normal. When you're taking sample size.
3 is normal. 3 is right.
But when I do on this sampling distributions, when you do skewed and you do 5 for n equals 5 and animate it, it's still normal.
Oh.
I mean, unless I'm doing it wrong.
It is normal, but it's, oh yeah. I don't know.
But maybe it is a little skewed, right?
Yeah, when I do 10,000 again, let's do 100,000. Yeah. Well, I only think that it's not normal because of the definition when they had us do that number 6 on the homework. Because it says when is it normal? And there's 2 ways it's normal. Is if the parent population is normal, which this says it isn't, it's right skewed. And the other way is if it's more than 30, that's the central limit theorem. But this is 5. I think that's why they gave us a 5 question.
What number is that one again?
It's number 6.
Okay, because the sample size is actually. All right, let's just go with skewed right. We always have a second chance. So
Yeah, we can check back. Yeah.
So 4 and 5 are normal.
Yep. And I have normal for 6.
Okay. So
okay,
7. When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small.
Okay, wait, let's see. It says guaranteed to be normal if the parent population is normal. And I don't think it matters if the
it doesn't matter if the sample is small or large.
Normal, so yes. And population normal and large, yes.
Oh, we're choosing all the correct responses. Data are drawn from a population that is right skewed and the sample is small, so that's no.
No.
And data are drawn from a population that is right skewed and the sample size is large.
Yes.
And that one is yes.
Yeah, so we have 3 checked.
Yes.
And that backs up our other one earlier.
Yeah. Okay.
Okay, 8. Which of the following gives the best explanation of the central limit theorem? Okay, so in my notes I have if the sample size is large, the sample mean will be approximately normally distributed. So I think if the sample size is large, the shape, oh wait, sample size, if the sample size is large, where am I? Oh, the sample mean will be approximately normally distributed. Sample mean, oh yeah. Then I think
so
it's
if the sample
if
size
the
large
parent population.
from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution.
Yeah.
Is that what you're saying? The first one?
Yep.
Yeah. Yeah.
Because yeah, it's not close to the population mean. That's not it. That is
Yeah.
that's the other one.
Because if the parent population is normal, then the mean will always follow a normal distribution.
Mm-hmm. Okay, good.
So
Okay, use the
use the
following to
following.
answer the next 4. What is the
Let
mean
X.
of the distribution of sample means? It's 10, because the mean is the same.
Yeah. Yep. And what is the standard deviation of the distribution of sample means?
So that's where we have to do the square root. Standard deviation. Wait, hold on. Yes, it is. Okay. So we're going to say, where is that? I put it in my notes. So we do standard deviation over the square root of the number. So number is 36, the square of that is 6. Standard deviation is 6, so it's 6 over 6, which is 1.
1.
Right? Yep.
Yeah.
Regardless of the distribution of the population, if the sample size is large, larger than 30, what would be the shape of the distribution of the sample means? Normal.
Normal.
Yep.
Yeah. And what theorem would justify your response to the last question? Law of large numbers, right?
No, I don't think it's that one.
I think that is law of large numbers, because central limit is that if the population is normal, then the mean, or what we answered before.
Okay. As sample size increases, standard deviation. No, law of large numbers.
Maybe not.
Says the standard deviation gets smaller.
All right,
as
this is the law of large number.
Right. So do central limit.
If the sample size is large, then yeah.
Yeah. Okay, should we write down our little, should we make a note before we put it in?
Let me see.
So we remember what we did.
So we remember the answers?
Yeah.
Well, can't we see them after we submit?
Yeah, we can, but I tried that once and you have to click out and click back in, and I'm always afraid I'm going to lose it. Let me just try it. That doesn't even work. Okay.
Well, if one of us just submits it, then I
Okay.
still have it open.
I'll submit it. Here we go. Submit. Yes, submit. And it is, dang it, I missed number 8. Which of the following gives the best explanation for the central limit theorem?
What?
And that was the only one I missed. I had put if the parent population, that one. Is that the one you had?
Okay. Yeah.
So we got to choose another one. So I'm going to click back in and we're going to choose another one.
Maybe
I'll click back in and then mark them. And then you can guess one of yours and then you can click back in with me. Okay, start quiz. Okay. True, safe. True, safe. 3 is skewed right. Normal. 5 is normal. 6 is normal. 7 is, oh, it's check all the, okay. Data are drawn from a population that is normally distributed and the sample size is small. That's not the one, right?
No, that is the one. It's data drawn from a population that is normally distributed and the sample size is small is yes.
Okay.
Data are drawn from a population that is normally distributed and the sample size is large is also yes.
Mm-hmm.
The only one that it's not is the data are drawn from a population that is right skewed and the sample is small.
Oh, yeah. Okay. Okay, I'm going to skip 8. 9 is 10, and 10 is 1. And 11 is normal. And 12 is central limit. All right, number 8. So let's see, if it's not that first one, for bell-shaped data, I don't think it's going to be that. It's not the 68, 95, 97.
No.
Okay, so then we have if the sample size is large. Okay, wait. Central limit theorem states that if the sample size is large, that X bar will be approximately normal.
I'm guessing it's the last one. If the sample size is large, the shape of the distribution of sample means will be approximately normal. I don't know why it's not the first one, but
I know, it's weird. Okay, we'll go with that one. So send your sentence.
I'll submit mine.
Okay, yeah. See if you got it right.
Yep, that was it.
Okay, good. And I'm going to put mine in. And 14 out of 14. Awesome.
All right.
All right. Yay. That was cool.
We did it.
Good work, team.
I actually felt like I understood that too.
I know. We're getting it. Yeah.
We are, which is nice. Okay, so then let's just plan on Wednesday at 7:30 our time.
Yeah, Wednesday, 7:30. Perfect. Yep.
So awesome.
Cool.
All right.
Thanks,
Well,
Ashley.
I'll see you Wednesday.
Okay. Thank you.